I am going to email you the handout that I did yesterday. I copied it and I sent it to my email. I just haven't sent it yet, so I'll send you that. It's just extra problems. Let me go ahead and take a minute or two and go over trig. Okay? Now, how much of the test on derivatives is going to be trig? 10, 20%. Hubert, why? Because 80% of this test is not about you being able to memorize the trig derivatives. That's not what 80% of this test is for. Is can you do the power rule, product rule, quotient rule, and chain rule? So with that being said, I'm going to go ahead and put this up and let you copy it down so you can start memorizing it. And I also threw in the logs also. So go ahead and write that down, and we're going to go over a couple of them just so you can see how to use them. But it doesn't do anybody any good to go over the trig rules until you go over the chain rule. Because most of the time when you're doing a trig derivative, you have to use chain rule. So with that being said, go ahead and write those down. And this completes pretty much everything as far as derivative mechanics for this Chapter 3 test.
I think you just stopped venting.
Okay. Yeah, I don't see it anymore.
We don't see the content.
It was.
Okay, hold on.
Yeah, I don't see it either.
I sent it. I got witnesses here.
I'll send it again.
We all know it's the Russians. There, it should come through now.
Oh,
there it is. Make sure you maximize it as full as you can so y'all can see it. Pendleton, y'all got it?
Yeah.
Okay, I guess that was a yes.
You have a work email.
Somebody done called my department yet. I done got an email.
Shit, that was me.
Yep, I figured it was. All right. So, of course, if I ask you what the sine of x is, the derivative of the sine, you'd say it's cosine. If I say the cosine of x, you say it's the negative sine. But what is the coefficient of x? The coefficient of that x is what? 1. So, technically, you multiply, you take the derivative of what's inside. What's the derivative of 1x? 1, Hubert. And you pull the 1 out front. And the technical derivative of the sine of 1x is 1 cosine of 1x. Now, you have to get in the habit of doing that because I'm sure that most of you, even the ones that suck at calculus, I'm sure most of y'all will get the derivative of sine right. But I'm not going to test you on the derivative of sine. And most calculus teachers don't test you on the derivative of sine. They're going to throw a number out in front of it and a number in front of the x. Then you have to revert to what? The chain rule. So it is useless to teach the trig functions until you learn the chain rule. So here we go. I'm going to give you 2 sine of 4x. Now notice I put parentheses around that 4x. Why did I put parentheses around that 4x? Well, not to crowd it, yes, that's one reason, but that's not the reason.
Isn't it to signify the chain rule?
Thank you. So you were the one that listened. Who said that?
Ms. Rowland.
Miss Rowland, you're gonna do good. Okay, you're not going to get a degree in global studies. You're going to get a degree in a winning degree. So that's good. You listened. The parentheses basically says, okay, guys, you got to use the chain rule here. I'm what's inside. So what is the derivative of the sine? The cosine. So that's easy. You do 2 cosine of 4x. But then you have to remember what? The derivative of what's inside is what? So the actual correct answer is 8 cosine of 4x. That's why Hubert teaches the trig functions after the chain rule. Because like I said, 99.9% of y'all can memorize this, and if I asked you f of x is equal to cosine of x, 99% of you will say f prime of x on the test is what? Negative what? Negative sine of x. That, I mean, that's just memorization. That's like biology, okay? To truly understand the trig functions, you have to have chain rule. What is the most common mistake? This is what students say is the answer. This thing cannot stand to write in dots. It goes crazy when you write in dots. That's what people say the answer is, and that's not the answer. They forget to do the chain rule. And then, of course, if you did the cotangent,
excuse me, do you mind
3x.
the board? I can't see it.
I'm sorry, what?
Can you reshare the board? I can't see it.
Oh. Who was that?
Mr. Howell.
Oh, okay. Let me go back. Hold on just a second. Here it comes. There, I just sent it. So, what is the derivative of the cotangent?
I still can't see it.
Well, it takes a second.
It might be hiding behind another window.
I'm sorry, what?
It might be hiding behind another window if someone left it open.
Okay, minimize and see if you can get it.
Oh,
No, I
everybody
still
see
can't see it.
You still can't see it, Mr. Howell?
What's
Okay,
that?
I'll send it one more time.
If you hover over the taskbar icon, several windows should open up, at least miniature versions. See if it's one of those.
See if it's one of those. It's there somewhere. It should be blinking.
Yeah.
I'm not seeing it anyway. This is the only tab I have open.
Okay, I'm going to try it again. Are you on an Apple?
I am.
Apple should be outlawed.
It's been working every other class, though.
I know. Okay, I sent it again. Look for something blinking. Anything?
I don't see anything, but I can follow
Okay.
along by listening.
All right, what I want you to do is X out. I'll remove you. I want you to X out, and I'll bring you back in, okay?
All right, thank you.
Mm-hmm. Howell. There he is. Okay, Mr. Howell, just let me know. It should automatically ask you where is. I thought he come in. He hadn't come in yet. Did call him in, didn't I? I know what happened. Somebody threw him in a van. Cannot be reached. They just stuck him in a van. Now they're going to beat him up. Tell him who to vote for. There he is. All right, it should automatically ask you because I am presenting.
Oh, thank you.
You got it?
Yep.
Okay, good. All right, so what is the derivative of 3x? 3. So you're going to take the derivative of what's inside, and I'm just going to bring it out front. And you can do that. There's no law that says you can't do that first. That's fine. And now I'm going to do what's the derivative of the cotangent? Negative cosecant squared of 3x. Negative cosecant squared of 3x. So is there a big deal about the trig functions? No. As long as you know the chain rule. Question, gripe, complaint. Now, as before, this one right here will get you. I showed you that before. You got to know the chain rule. All right? E to the x is biology. The derivative of e to the x is e to the x. The antiderivative of e to the x is e to the x. If you miss the derivative and the antiderivative of e to the x on test, you don't what? Tell anybody. Okay? Because e to the x is e to the x. That should be the easiest derivative and antiderivative that you know of. But if I throw a negative 1/2 in front of that x, you got a different animal. You got a chain rule. So, with that being said, we're going to erase this, and I'm going to do just one or two of e to the x's. And then we'll get back to what we were doing with the chain rule. So, e to the negative 1/2 x and e to the 4x. Now, if you need to, take your handy dandy blue pen and put those in parentheses. And the derivative of e to the negative 1/2 x is e to the negative 1/2 x. And what's the derivative of negative 1/2 x? Negative 1/2. Why is the negative 1/2 in front? Because you had to use the chain rule. So therefore, 4e to the 4x. Once again, I'll say it again. The most missed questions on this test have to do with the trig functions and the e to the x functions when you use the chain rule, when you have to use the chain rule. Students forget to do it or they don't understand. So make sure you know how to do some of those problems. And I put some trig functions on there. I think I called it trig, and then I called it trig with chain rule or something. Question. All right, so I don't mean to treat it like it's minor, but when you compare it to the power rule, product rule, quotient rule, and chain rule, it is minor because, like I said, is there much calculating right here? No, it's just memorization. Uh-oh, something happened. We lost somebody. Who'd we lose? Easley, you still there? Okay, something is happening. Okay, just chill for a second. Okay, stand by a few minutes. Let's see if everything gets fixed. Okay, Pendleton, are you there? Easley, are you there? Ooh, that sounds awful. Okay, we'll try it again. Easley, are you there? Pendleton, are you there?
No.
Okay, turn your cameras on, please. Everyone is breaking up audio. What about my Skype people? Some of you Skype people talk.
I can't understand a damn word.
Oh, can't understand the word.
Okay, Skype, Mr. Hitt, say something. Mr. Howell?
Something.
It's just all vocal noise to us.
Okay, it's Anderson campus, Pendleton campus, and Easley campus. We're having problems, guys. Okay, so just let's bear through it. Easley's up there having a party. I don't know what they're doing. I wish somebody would tell me what the heck's going on. The last 3 days we've had these problems. And we ain't never had these
It's
problems.
probably the internet. Because it will work for like, it will stop for 5-10 minutes and then I guess you guys are connected to the internet, so it might be, that's why it's still connected.
So AT&T is doing it too. Yeah, I noticed that at my house. Okay, guys, just stand by. AT&T should be broken up.
Can you try to open something on the Chrome?
I'm sorry, what?
Can you try to open something on the Chrome?
Yeah.
Refresh something. So,
Pendleton, you there? I think Pendleton's gone. Yeah, it's not working. Well, I'm gonna put pause. Somebody remind me.
I think you can do it either way.
Welcome.
Appreciate it. Appreciate the interaction, losers.
Uh-oh.
Uh-oh, what?
My computer died, that's all. Easy fix.
Oh, and I would not do algebra on this one unless you just like pain.
Maybe some of us are masochists, you don't know.
Yeah. Well, knock yourself out. That's going to be about a 9-term polynomial on the bottom.
Ew.
That's the way I'm going. You don't have to do that.
It's the -30.
You don't have to. But that's what he
Oh, you just.
he just pulled it up and made it negative. And then use the product instead of a question.
First times the derivative of the second plus the second times the derivative of the first. And the derivative of this guy is going to be a mess, but -3 parentheses, well, do it. Got to throw that innovative teaching in there. Parentheses, -3, parentheses, -3x squared minus 4 to the negative what? To the 4th power. And then what's the derivative of what's inside? Negative what? Negative 6x? Yes or no?
Yeah.
Okay, plus parentheses, -3x squared minus 4 to the negative 3rd times 3. Okay, guess what? All your calculus is done. Now finish it. People wonder why they fail calculus. It's only 10% of the problem. I have to answer that. Hello.
Yeehaw.
Carol, hey, this you.
Like every single person in this class does not know that song.
Okay.
You're right.
I think it was Trevor Noah. We went to a show of his, and he was like, you white people, you love that Sweet Caroline song. And all he did was say Sweet Caroline, and the entire stadium went, dun, dun, dun. He was like, you see, you can't help it. It's part of your DNA.
Uh-huh.
Yeah, and these are like whitest things ever. Well, that'll get people singing, and then Journey. No. Automatic.
Okay, I'll be down there at 4:30. I get out of class at 4:30. I'll be down there between 4:30 and 5. Thank you, Gerald. Bye-bye. Sorry about that. All right. So, we got 3x minus 1. And then a cluster right here, but I'm going to take that -6 and that -3, and I get what? 18, right? And then I'm going to get -3x squared minus 4 to the -4th power.
Wait, what about
Now,
What about that?
where's that? Oh, sorry. Thank you. Okay. Now, if you notice, I'm doing everything step by step. Why? Because with these type problems, with all this algebra, as you can see, you can make a careless what? Mistake. Okay? So I'm going to rewrite this because I got negative exponents, and those negative exponents are going to give you nightmares. So let's go ahead and rewrite this one. 18x times 3x minus 1 over -3x squared minus 4 to the 4th power plus 3 over -3x squared minus 4 to the 3rd power. Now let's go back to pre-algebra. 1 over x squared plus 3 over x. What do you go with when you get a common denominator? Do you go with the highest degree or do you go with the lowest degree? I'm sorry, I heard mumble. What'd you say? Which one will both of these go into? The highest degree or the lowest? The highest exponent or the lowest?
Highest.
Highest. Go with the highest because x squared won't go into x. X will go into x squared. So the common denominator will be the highest degree. So what's the common denominator of blah, blah, blah to the fourth and blah, blah, blah to the third?
Fourth.
The fourth. So you're going to use this one as a common denominator. So I'm going to take my handy dandy
Notebook.
No, my handy dandy, whatever you call this thing, and make it small. You know they're coming out with the third Blue's Clues?
No.
Yeah, he's going to have purple shirts.
How old?
19.
You know, the first guy, he was good. What was his name? Steve. And the second guy, he really sucked. The second guy sucked. Now they got
Joe.
this other guy, and he's going to have not green shirts, but purple shirts.
He was a pedophile, wasn't he?
Yeah, I don't know.
If they give him a purple shirt, he's going to look like a wiggle.
Well, oh gosh, don't even, oh gosh. I would
He's
not
like,
let
"You're
my
giving
kids
flashbacks.
watch the
Don't do
Wiggles.
that."
My kids wanted to watch the Wiggles, and I said no. I said hell to the no. You're not watching the Wiggles, and you're not watching Caillou, and there's something wrong with that kid. And you're not watching the Teletubbies.
God, I hated Caillou.
You know, the little baby in the sun from Teletubbies is now all grown up. I saw that in a clickbait article.
He's never going to live that down either.
And he's probably deranged, isn't he?
As a chick, yeah, she's kind of out there.
I thought so. And Caillou, there's something wrong with that kid. He never grows any hair. There's something wrong with him. I think he's got cancer or something.
Holy shit.
Think about it. How many times have you watched Caillou and he don't have any hair, and all the kids around him have hair?
Might have alopecia.
They never took him to the barber shop and shaved his head. He never had any kind of growth on his hair. There's something wrong with that kid. All right, so sense of humor. Remember, grow one, develop one. -3 x squared minus 4. And I'm doing this for a reason, okay? Because the answer is written in terms of a common denominator. Because 90% or 80 to 90% of passing calculus 1 is not calculus. It's algebra. So, how many times will blah, blah, blah to the fourth go into blah, blah, blah to the fourth? One time. One times this is this. How many times will blah, blah, blah to the third go into blah, blah, blah to the fourth? Blah, blah, blah times. 3 times -3 x squared minus 4 to the first power. Now it's just an algebra 1 problem. Because now you can put everything over just one denominator. The common denominator is -3 x squared minus 4 to the fourth power. Now, finish the top. And if you can't finish it, that pretty much means what? Global studies.
You suck and you should give up.
Yep, and go into a underwater firefighting degree, rack up a lot of student loans, and complain to the government that you can't pay your student loans because you can't find a job because there's no jobs in underwater firefighting. What's 18 times 3? Dang old 54?
Yes.
So that's 54 x to the second minus 18x minus 3x minus 9x squared minus 12 and 54 minus 9. What is that? 45?
Yeah, 45.
So that's going to be 45 x squared minus 18x minus 12 over negative 3x squared minus 4 to the 4th power. I know you can factor out a 3. You might want to go on. Let me look at the answer because I know you can factor out a 3 up top. You might be able to use reverse FOIL. Let me see if they took it on down further. Yep, factor out a 3. That's it. So that's good enough for government work. Does everybody see where you can factor out a 3 on numerator? I hope. Now, the reason I picked this problem out is to show you how something as simple as the chain rule, the product rule, or the quotient rule can get you on a test. But is it the calculus that gets you, or is it the algebra? It's the algebra. If you want to know the truth about it, only 5%, 5 to 10% of this problem is calculus. And that's in blue.
And
that's a good test question.
How do you know when to stop if you can keep going? I mean, if you're on a test or something like that.
When in doubt, stretch it out.
Okay.
It's easier for a teacher to give you credit for going too far than not going far enough.
Oh, true.
And Miss Gusmus, you play the piano, correct? How do you know when to do your fingers a certain way on the next page or the next what? Next bar or whatever you want to call it. How do you know to do that?
I don't know. It's preference, really.
No, it starts with a P. What is it called? Practice. Yeah, you have to what's that word? Work hard at it. Okay, let's do a narrative. And again, I'm working with the silent here. I'm working with the people that don't talk. So I have no idea what y'all feel about what we're doing. I don't know if it's easy to you. I don't know if it's hard to you. So
I'm familiar with this stuff.
Say again?
I said I'm familiar with this from my college.
What did she say?
I said I'm familiar with what we're going over right now from my last semester.
Okay, so you are familiar with it?
Yes, sir.
Is there anybody here that's really sucked at it before? They're not going to say anything.
This is the first time I'm seeing any of this, really.
Well, good. Well, then it's going to help you out. All right, let's do
I never
this
had pre-calculus or anything like that in high school, but that was a long time ago anyway.
Well, you should. Hopefully, you're seeing that, and the only way, and a lot of people are saying, well, why are we still on these 4? And I keep telling y'all, if you don't learn these 4, you might as well just go ahead and drop and just forget about Calc 2. So that's why I'm drilling it. All right, so f of x is equal to the 5th root of x squared minus 3 over negative x minus 5. Do it however you want. I'm going to move it up in the top left-hand corner so I have plenty of room. They're doing it with the quotient rule. I don't know if they're doing it with the quotient rule. Let me look. I don't know if, yeah. They're starting with the quotient rule, but you don't necessarily have to do that. If you want to bring the negative x minus 5 up, you're welcome to. I personally like the product rule, but the only preference is, why would you use the quotient rule over the the product rule. Do you know at the end of that last problem when we had to find a common denominator? Yes or no? You don't have to do that with the quotient rule. Usually the quotient rule gets that taken care of because of the square. Denominator squared. And you may say, well, Hubert, you're still doing the product rule and the quotient rule. Why aren't we doing the chain rule? You are doing the chain rule. The chain rules are nested in these problems. I'll go ahead and start it off for you. Denominator times numerator prime, and that's going to be x squared minus 3 to the 1/5 power. Then I'm going to put a prime there, but I've got it in blue, so you know I'm going to take the derivative of it. Plus the numerator, x squared minus 3 to the 1/5 power times denominator prime. Denominator is negative x minus 5 prime over denominator squared. Negative x minus 5.
Must be minus.
Say again?
Oh yeah. Are we supposed to subtract?
Yep, you're right. Thank you. Oh, me, oh my. Thank you. There. And brackets. All right. So, negative x minus 5, you're just going to rewrite that. And then this is going to be 1/5 parentheses x squared minus 3 close parentheses 1/5 minus 5/5. And I'm going to go with my red brackets here. And that's going to be x squared minus 3 to the 1/5 power and negative 1 is your derivative of negative x minus 5. And of course I really don't care about the denominator because I'm going to worry about that later, so denominator squared. So now I'm done with my calculus, so I'm ready to condense. So that's going to give me negative x minus 5 times 1/5 parentheses x squared minus 3 to the negative 4/5 minus parentheses negative 1 times x squared minus 3 to the 1/5 power. And remember, that's still in red. And all that over denominator squared. Now that little squiggle line and square, you don't want to go into another calculus class and do that because they'll have a conniption. Okay? But I think all of you understand that instead of writing it over and over and over, you can just put a squiggle there. Just don't forget it at the very end of the problem. All right?
Are we
Here,
supposed to take the derivative of x squared minus 3?
did I not take the derivative? I'm sorry.
Okay.
You're right.
Sure.
You're right. 2x. I don't know why I didn't. I wanted to make sure y'all were paying attention. All right. So 2x times, that'd be 2x over 5. But you can bring all that out. But what's going to happen to that x minus? What can we do with that x minus? We can do something. Well, let's do that. Let's do that at the very end. So that would give us 2/5. And that's going to give us negative x minus 5 times, I brought the 2/5, and I'm going to bring the x out too. Okay, and that's going to give us x squared minus 3 to the negative 4/5. And then what does that do with that negative? And that negative makes it a positive, plus x squared minus 3 to the 1/5 over denominator squared.
X squared minus 3.
Make sure I didn't make another mistake. Oh. Where's minus x squared?
After the negative.
What?
Oh, okay.
Negative and a negative makes a positive. And they left it as that because that would be a mess to try to take it on down. The only thing is, you know where I pulled out the 2x and the 1/5? They didn't do that. They left the 1/5 in front, but that's fine. The only thing different from my answer and their answer is this right here. I pulled everything out. I pulled this out because it's multiplication, and this out. Okay, and that left 2/5 x. So this is your answer there. Now, those are two good problems. The problem we did before this one and this one. If you can do these two problems, then you're good to go as far as the test goes. Now, realize that you do have trig and you do have natural log, and we'll go over those later. Tomorrow, we're going to go over homework questions. I've got about 6 or 7, and plus you need to send them if you got them. Send homework questions to me because we're going to do that tomorrow. That way, people can get their homework done throughout the weekend or whatever. I'm going to extend the homework till Monday or whatever. I can't remember. I cut some of them off because some of y'all gaff it off, so that's why I put dates on it. So I'll probably extend those to Monday, probably after class. Okay?
Thank you.
Who's got questions? Okay, let's go ahead and do the roll, get that out of the way, and then we'll give y'all a peanut butter sandwich and a cup of Kool-Aid.
What the hell does that even mean?
Walk y'all down to the water fountain, single file.
What?
Yeah, I have to do that because we're in kindergarten. I have to take the roll.
Sure, everybody's
Sure,
here.
y'all are here.
I was like, where is he going with this?
You wasn't here
Here's my
yesterday. We discussed this yesterday. You wasn't here. You were off drinking, partying, doing whatever you do. Wednesday. Okay, Bryson.
Hey.
Castles, she's not here. She had to go to the doctor. Greco.
Here.
Gusmus is here. Howell is here. Jones.
Here.
Underwood is here. Williams.
Here.
And Miss Wilson. She's on the side of the road. Stranded. Flat tire. Okay. Pendleton, if you don't have any questions, go ahead. See you tomorrow. Get the homework done. Next is this class, which is, this is Anderson. So Brock is here, Barnes is here, Yabi's here, Patel is here, Rudiger's here, Story is not here. And last but not least, the Easley campus.
Oh,
Easley campus. Oh, this one.
last and least.
I didn't pull the last one out. Hit is here, Roland's here, Sterling's here, and Swords is here. Okay, I will extend the homeworks probably till Monday or Tuesday. I'm going to do that right now. And if anybody has any other questions, just give me after class. See y'all.
Bye.
Let's see, homework. Assignment. Oh, let me turn the recorder off.